Let's say you have to build a reservoir. What's the best way to do it? If you build a dam across the main channel of a river, that's going to radically change the natural flow of that river. How can you still build a reservoir but reduce negative impacts to that river system? One solution is to build the reservoir to the side, off the main channel of the river.
The benefits of an off-channel reservoir opposed to an on-channel reservoir are that there are typically fewer impacts to fish and wildlife habitat in the form of impacts to wetlands or to the flow in the river itself, fewer impacts to riparian areas along the main channel of the river, therefore leading to fewer impacts to fish and wildlife.
One of the newest off-channel reservoirs is 50 miles southwest of Fort Worth in Somerville County. This area had relied solely on groundwater, but that's about to change.
This project will bring surface water to Somerville County, and we'll be able to provide surface water to all of Somerville County as well as the city of Glen Rose. With our off-channel reservoir, we have a weir that we built on the river to back up a pool of water for us to pump out of, and we've built a pump station right next to the river, which allows us to pump water up into this reservoir to keep it full.
The idea is to draw water from the river when flows are high. When flows in the main river drop below a certain level, set by the Texas Commission on Environmental Quality, the pumping stops.
We have bypass flow restrictions that are imposed on the water district by the TCEQ. What that means is we have to allow a certain amount of water to pass by our project and continue on down the river. That water that we let go by helps sustain the habitat and fishery below river from it. For example, this month we have a bypass requirement of 17 cubic feet per second. If the river gets a slower flow than that, then we can't pump at all. We can only pump what's above our bypass requirement. So anything above 17 cubic feet per second, we can pump during this month.
Another advantage of off-channel reservoirs is greater control of what land actually goes underwater. If special sites need to be avoided, the design of the reservoir can be adjusted to protect them. That's what happened 30 miles west of Houston, next to the Brazos River.
Where we stand right now is just south of a wetland known as Alligator Hole that is right beside the future Allens Creek Reservoir. The original dam structure was designed to follow the contour of the main stem of the Brazos River, and it included this rather substantial wetlands area known as Alligator Hole, which was approximately 1,300 acres of wetlands. And it became real apparent that we needed to do something to protect this significant resource that we had. And so the project was reconfigured to exclude the Alligator Hole wetland, which essentially cut the wetlands involved that would be inundated by this project almost in half.
Just west of the Brazos flows the Colorado River. It's here, near the town of El Campo, where a future off-channel reservoir may provide a variety of solutions.
The project's designed to meet the needs of two different areas. One, the greater San Antonio metropolitan area, which is growing very rapidly, but also the entire lower Colorado River basin, including the agricultural users downstream, mainly rice farmers, as well as the Highland Lakes interest. If it goes forward, the project has to guarantee that the lake levels will be higher than they would be without the project.
The Lower Colorado River Authority administers the lower 300 miles of the Colorado River. This includes 6 dams and lakes between Austin and Llano, generally called the Highland Lakes. This project would build the off-channel reservoir down near the coast. Water from the reservoir would go to the San Antonio water system. A pipeline would connect the reservoir with San Antonio and provide water there for 50 years.
We're trying to balance the upstream and the downstream interests so that we can have long-term viability for all the different users in our basin at the lowest possible cost, while still meeting the needs for San Antonio during this interim period over the next anywhere from 50 to 80 years.
San Antonio's sole source of water has been groundwater, but as the city continues to grow, other sources need to be found.
Historically, we have relied almost exclusively on the Edwards Aquifer, and little by little we are getting diversified sources. And this will really almost put in a situation where we're 50% on the aquifer, 50% water out of this region. And this will help out in that diversification process. It's important that all of our neighbors know that while we are still going to rely heavily on the Edwards Aquifer, that we are looking at other water resources to help out those other entities that do rely on the Edwards Aquifer.
The project is still in the planning process, but close scrutiny is underway in a variety of areas.
There's a whole host of studies. We have a scientific advisory team that is doing technical studies on everything from groundwater, environmental impacts, conservation, hydrology, socioeconomic impacts, climate change. It runs a broad gamut of issues that we're trying to take the most comprehensive look possible to ensure that every aspect of the project is reviewed in great detail and we know exactly what sort of impacts there will be on our basin and the river system.
The impacts don't end at the river, but extend into the estuary of Matagorda Bay. It's here where fresh water flowing in from the river mixes with salt water from the Gulf. This creates a mosaic of marshes, tidal flats, and open bays, which nourishes an interdependent web of fish and wildlife.
For juvenile finfish, shellfish, shrimp, crabs, the edge habitat is vital when they're in their development stages. It gives them somewhere to hide from the predators. This habitat's typically close to freshwater sources. In this area, we're close to the Colorado River, so the inflows from the Colorado keep this area of the bay fresher. The water here is brackish. It allows for their development. And as they grow, then they'll start to utilize habitats out in the larger part of the bay.
We usually dump these out and then we'll count them each sweep, and then we continue sweeping these samples until we don't collect any more. That's a great example of how productive these marshes are. If you extrapolate this over all the marsh edge that's out here,
right,
realize how vital these areas are to the bay.
An independent panel of nationally renowned experts reviews all the studies to ensure that the results are valid and unbiased.
I will say that without any equivocation, that it's probably the most comprehensively studied project that's certainly ever been undertaken in Texas with respect to water resources. And if there are impacts that are greater than expected, that's going to come out in the studies. They have done a very, very comprehensive job of looking at every possible impact and consequence of this rather substantial project.
It's called Dermo.
Actually, the project is reaching a fairly climactic stage in that on or about the early months of 2009, two things will happen. One is the LCRA board will meet and determine whether all of the criteria set by the legislature as requirements for the project have been met. And that requires a formal finding of the LCRA board. For example, will the water in the Highland Lakes be maintained? Will the agricultural water for the rice farmers be further secured? Will the freshwater inflows to the bays and estuary be adequate? So that finding will take place around the first of the calendar year 09. The second extremely important meeting will be a joint board meeting of the Lower Colorado River Authority and the San Antonio Water System, at which they will decide whether or not to proceed with the project. So we're reaching an extraordinarily critical stage.
The good news is we have learned so much about our river as a result of this project. There's great hope that regional cooperation between two river basins can work, that we can share water collaboratively and find a win-win solution for the long-term water supply needs for a state that really needs a lot of water to meet our growing demand.